All right, today we are very pleased to have Brendon Samuels with us. Brendon is a PhD student in the Department of Biology at Western University, and he received his master's degree in neuroscience at Western, and also his bachelor's in psychology is from University of Guelph. Um, so Brendon is quite active and he's a volunteer to support bird conservation through the City of London's programs and also various environmental initiatives at Western's campus. So today he's going to give a very interesting talk related to birds, reflections, and the hidden ecological cost of glass. Thank you again, Brendon, whenever you're ready.
All right, so I'm just going to share my screen here. Just a second. You'd think I would have figured this out after all this time. Just a moment. Okay, can you see my screen?
Yes, we do. Yeah.
Excellent. All right, thank you very much for that introduction. It's a pleasure to be here today. Thank you very much for having me. I spend a lot of time talking about my research topic with folks working in conservation space and in biology. I feel as though it's really important, though, that we communicate as biologists with the practitioners who actually have power to influence the way that our cities are built. And so I hope I can impart you through my presentation with a little bit of knowledge that could help you as students in engineering in your future career path, wherever that might take you. So the title of my talk is Birds, Reflections, and the Hidden Ecological Cost of Glass. Before I begin, I want to start my presentation with a different type of land acknowledgement than you might be used to hearing. Of course, our university is built on traditional territories of several First Nations, but I want to talk about what that means at a landscape level, because I think it's quite relevant for the subject matter of my talk today, being birds. The City of London likes to call itself the Forest City, and we do so despite the fact that there isn't a ton of forest left here. In fact, the name comes from what used to be here before our city was built. If you were to have arrived here in Southern Ontario a couple hundred years ago, this is what you would have seen. And more specifically, the type of forest you would have found here is called Carolinian forest. This is a rare type of forest in Canada. It contains the most biodiversity as the richness of life and interactions between life found anywhere in all of Canada. So ecologically, it's really significant. And I think it is important to reconcile that when we're talking about nature, this is what was here not so long ago, right? What we're doing in the built environment nowadays around conservation really is about trying to maintain, to some degree, the conditions that were present here for millions of years as life evolved as we know it. So if we fast forward a little bit to about the mid 1800s, this is what the City of London started to look like. So you can see, of course, it's taking form. This is the downtown core as we know it today. And, you know, it had humble beginnings, right? Like it was quite a lot smaller than we appreciate our cities to be today. So this map was drawn in 1872. London had already been around for several decades prior. And it was just about 5 years later that we started to have new types of buildings crop up. So back then, if you were lucky to have windows on your home, this is what they would look like. And we still see windows like this in buildings today, but they're less common. Of course, you still get to look outside your window, but you know it takes up a relatively small proportion of the total surface of a building. And similarly, you know, when we look at other types of structures, here are the two buildings that comprise the University of Western Ontario, which went by a different name back then. When it first opened in 1878, I think they only had like 15 students in a class. But again, looking at the buildings, the windows are relatively small. And this was just, how buildings were fabricated back then because of the availability of materials and the architectural style and that sort of thing. So let's jump ahead in time again and arrive back at London today. This is what the downtown core in London looks like. And despite the green that you see, in fact, that's not really the forest as it once was. A huge proportion of those trees are actually introduced species. They're trees that were brought over from Europe or from Asia. And unfortunately, even though they look green and they provide us with shade for human purposes, they don't really advance the ecology of the Carolinian forest that was once here. But beyond that, we see profound changes in the ways that we're building things. So if you were to have bought a home in London nowadays, you would be more likely to opt for these big floor-to-ceiling windows, the type you see in the top right. Glass railings have become super fashionable. And again, we see that iterated in other types of structures. So you might recognize these two buildings from Western's campus. The Western Interdisciplinary Research Building was completed a couple years ago, and the Amit Chakma Engineering Building, which I'm sure you're all familiar with. And so the use of glass in building construction has just exploded. It's become associated with aesthetics and the modern design of buildings that appeal to us. And yet people who design buildings and people who occupy buildings still have attachment to the forest that was once here. We still really value connection to nature. And I think that's part of why these big windows are so appealing to us. They allow us to enjoy the comfort of being indoors year round, but still have access to the natural world through what we see in the glass. For instance, in the bottom left corner, that's a patch of old growth forest that exists right in the middle of Western's campus. If you're standing on UC Hill, the big sprawling famous field at Western, and you turn to your left facing south, you would find this little patch of forest tucked behind the International and Graduate Affairs building. And when you enter that building, you immediately get the impression that you're almost immersed in nature despite being inside. You look out your window, giant wall of glass, and there it is, the forest in all its glory. And the people who work in this building really enjoy that aspect of connection to nature. Unfortunately, there is a hidden cost to having this connection with nature and designing our buildings in this way. The International and Graduate Affairs building, according to my research, kills the most birds of any structure on Western's campus. The photos that you see here were taken by me on separate days, and the birds that you see in my hand were killed in the span of just a few hours in the morning as they were trying to pass through Western's campus. They were killed by collisions with this structure. And the occupants of this building, I've spoken to many of them, are aware that this goes on. They find it really disturbing. They find they're quite helpless to do anything about it. And this strikes me as a failure of design in the way that we hadn't considered when we built this, the cost that's sunk in building with huge walls of reflective glass. So I want to talk to you today about the work that I'm doing on this issue. Of course, I study the reasons why birds fly into windows. I want to know why it happens, but my research is really focused on achieving solutions. So what can we do to window glass on buildings to prevent birds from crashing into them? And the longer I spend doing this and talking to different types of people in the private sector, in academia, in government, the more I realize that we actually really need to consider the human dimension of the problem as well, and not just what birds are going to see and avoid, because unless we can convince people that this is a problem and that the solutions are worth adopting, it might as well all be for nothing. And so a huge portion of the work that I do involves understanding the relationships that people have with windows and the cultural significance of that, and how we can shift that in a direction that would be more ecologically sustainable. A guiding principle for my research that I'll return to later in this talk is that hypothesis that the risk of a bird flying into a window on a building or avoiding a window on a building has to do with sensitivities of its visual system. So how it actually sees while it's flying. So I'm going to start with just a general overview of why birds hit windows. It is a little bit complicated, so I'm going to go through a few very common scenarios when this occurs. So it was once believed that this was a phenomenon that mostly happened at night. And people would find these birds dead in the morning, and they would conclude that birds were flying overnight and in the dark and they couldn't see anything. And that's, they just smacked into the object because of a failure of detection. And we know now that actually this does happen at night, but it happens for different reasons and it happens less than we thought. So typically where you see a lot of birds crashing into buildings at night is in urban centers where you have a lot of light pollution. So these are places where lights are left on overnight. Seen here is London's skyline at night, and you can see there's quite a lot of uplighting or sky glow. And in fact, this is such a profound global problem that you can see the extent of light pollution from space. And there are a few interesting case studies that demonstrate how this affects birds. So in the image on the right, you'll see these two beams of light shooting up into the sky, and you might recognize this as the World Trade Center Memorial in New York City. It might be a little bit hard to see, but in that picture, you have these tiny little flecks of white. And actually, each of those specks is a bird. What they were finding within a year or two after building this was that birds were migrating through and they were getting drawn into this, these two pillars of light shooting up into the night sky. And the birds would just circle and circle and circle, and many of them would fall from the sky in exhaustion after doing this for hours. Some would collide with structures. And so the city implemented a program to monitor this and to turn off the lights when birds would start to accumulate in the sky. I drew a little comic, which I think does a neat job of explaining this problem. When birds are migrating, and I'll talk a little bit more about that, they use a variety of cues to know where they're going. They're generally crossing a huge expanse of land. And so, I mean, I get lost in London. I don't know how these birds manage to make it all the way to the Southern Hemisphere, but it seems that an important cue for them is using celestial cues in the night sky. So birds will monitor the position of the stars and the moon, and that helps them orient and know where they're going. When birds arrive in cities where there's a lot of sky glow, they can't use those cues as effectively, and they are drawn towards the light. And this leads to disorientation and collisions. And so really the straightforward solution to this is just turn off the lights at night when they're not necessary. Particularly around the timing of bird migration in spring and fall. The addition of light timers to buildings and use of fixtures that direct light downwards as opposed to up in the night sky really is beneficial for this issue. So another misconception I'd like to clarify is the type of structures that birds are crashing into. We tend to think about birds crashing into buildings like this. This is One London Place in downtown. And of course, it's a big glass wall. I think these types of buildings get a bit of a bad rap. And in fact, there's been quite a lot of research now that has explored where collisions are occurring that has suggested that actually collisions at high-rise buildings comprise less than 5% of the problem, and that most of the time birds are hitting windows, it's taking place at low-rise buildings and at homes. I mean, I think this is sort of intuitive when you reflect on the number of structures there are in each of these classes. We have only a few buildings in London that are giant glass walls, whereas homes and low-rise buildings, all of them tend to have some amount of glass and they're far more abundant. Another thing I would like to point out is the vast majority of the time that birds are hitting windows, it's taking place at or below the height of the surrounding tree canopy. And the reason for this is that's where birds are. Birds spend most of their day flying in the trees, looking for food, hiding places, that sort of thing. And so it makes sense that if birds are flying at that altitude, that is probably where the windows are that they're going to crash into. So I want to take a step back to the original question I asked, which is why do birds fly into windows? I think it's important to appreciate that glass is an artificial thing that animals would never encounter in the natural world unless people put it there. And it is a relatively new construct, as I showed. It hasn't been around for that long. And so when a bird encounters a giant wall of glass, they don't understand what it is. They don't recognize a reflection as being an illusion, really. When a bird sees an image like what you see on the right here, they perceive, those are just real trees on the other side. That's open space. I want to fly towards this extension of my habitat. And it has tragic consequences because, of course, all it takes is a split-second error for a bird to try and fly from one tree that's real to a fake tree in the reflection, to cost them their life. I want to also emphasize that there are different types of situations where birds might fly into windows for different reasons. So you might recognize this glass railing on the top left. This is at the front of the Physics and Astronomy building on Western's campus. I've walked into quite a few sliding glass doors in my life, and I never thought much of it until I started doing this research, but birds are liable to suffer the same problem, where the glass is just not detected. It appears, or it doesn't appear, and it's just transparent and invisible to them. But the appearance of a pane of glass can vary a lot, depending on a number of situational factors. So the time of day, to do with like the quality of ambient light coming down from the sun or the amount of shade, the composition of the glass. So how many panes are we talking about? What is the reflectivity of the glazing on the glass? The angle of the glass. These are all factors that can contribute to the appearance of reflection versus transparency. And so it's something to keep in mind that a single window pane could be more or less dangerous under different conditions. However, how birds actually see glass is not that well understood. A lot of this has just been sort of anecdote and put together based on where we see collisions occurring in the real world. And so this forms the basis of my research and trying to address how do birds actually see this stuff. One of my research projects involves going out into the real world on Western's campus and looking for places where birds crash into buildings. As you can see, and I'm sure appreciate being on campus, we have a lot of green space, and this provides a lot of meaningful habitat for the birds that live and migrate through here. Unfortunately, Western's campus also contains a ton of reflective glass surfaces. And for my research purposes, it's sort of useful that these different types of windows are made up of different types of glass with different combinations of glazing and structural features. And so I'm interested in looking at where collisions are occurring and how that is associated with different characteristics of these sites. So I'm going to share some data that I collected through surveys where we would go out and just look for birds, basically, back in 2019. So this is just a very high level overview from Google Earth. Over the course of 30 weeks, we monitored campus and found over 400 birds that had died hitting windows. We also collected some citizen or community science reports where if people found a bird, they could report it to us using a little hotline, which we found quite useful because it pointed us to some spots we weren't aware of. And so as you can see, it's a fairly diffuse problem. It's happening all across campus, but there are definitely certain clusters where we see more collisions than others. So this is the building that I showed you earlier in my talk, the International and Graduate Affairs building. And on the left, you see birds that we found in 2019. Quite a diverse variety of species. And of course, it's a big glass box, but we find different types of birds in the front and at the back of the building. The back being forest and the front being open space on a field. And I've wondered if that has to do with just sort of the ecology of these birds and where they're naturally occurring and what they're doing before they hit the window. But it's sort of hard to say with this type of data collection. What I will say is useful about collecting this data is it can point to where we should target mitigation. So if Western has a finite amount of money to spend fixing this problem, we should probably target it around places where collisions are really prone. And so I've had some meaningful dialogue with facilities management to point them in the direction of this is where we should probably be prioritizing efforts. What I also want to do in looking at different types of buildings is try and get an assessment of, is there something about the type of glass? So here are a few examples of windows that have killed birds on Western. And you can see just from my pictures that they have different quality of glazing. Some of them are more transparent, some of them are more reflective, some are a little bit bluer, some are and so what I intend to do next year is we're going to use a spectroradiometer and actually record how light is being bounced off of the glass under different ambient light conditions at different times of day. And then we're going to feed that into what's called a visual perceptual model to try and understand how birds would actually see that type of visual information. This is a really tragic picture. This is about half of the birds that I found last year on Western's campus alone through those building surveys. And I like this picture because it illustrates the diversity of species that are affected. You know, in the middle, we see birds of prey. We've got a couple of hawks. There's quite a lot of woodpeckers on the left side. On the top, we have aerial insectivores. At the bottom, we've got a lot of hummingbirds, and on the wings, we see yellow warblers. But within this image, I think there's a lesson to be learned, which is that it's not that there's one type of bird that this is affecting. We do know of some that are a greater or lesser risk. This is a very broad problem for all birds that fly. And in particular, I think we need to be concerned about how this is affecting species at risk. These are birds whose populations have declined quite a bit in recent years. So some of the ones that I found are shown here. I want to draw your attention to a bird on the right, the black one. That's called a chimney swift, and they're one of my favorites. And I'd like to use them as a case study to explain why a bird crashing into a window at Western has global consequences. So before I do that, I want to clarify that birds can be grouped into two types based on their movement patterns. So we have resident birds that occupy the same territory year round. So chickadees, northern cardinals, mourning doves, they tend to stay put in the same area. And these are birds whose populations are pretty stable right now. We also find that they're less prone to crashing into windows for some reason. And it might just be that they spend so much time in a given area that they learn where the hazards are and to avoid them. On the other hand, we have migratory birds. These are birds that they come and go each year in the spring and fall. They are at greater risk of collisions, and we're not entirely sure why. It might be because they're less familiar with the environments that they're passing through. And their populations, unfortunately, are in steep decline. So I mentioned the chimney swift is one of my favorite birds, and I included a little video I took earlier this year. Their name comes from their habit of actually sleeping and breeding inside of chimneys. And we have two of those chimneys at Western. This is a chimney on Huron's campus. Sometimes these birds will collect in like thousands within a single chimney for the night. But as I mentioned, unfortunately, their populations have really declined. We've lost about 98% of chimney swifts in the last 50 years. And so when we think about chimney swifts in London, they're only here for a few months of the year. They show up in late spring, they're around for the summer, they breed, and in the fall they depart for their overwintering grounds in South America. It's a huge journey for them. They really need to be physiologically prepared for that, so they have to eat a lot. It's quite dangerous for them. And so thinking about the birds that we're trying to protect here in London, especially the migratory ones, those are birds that don't belong to London per se. They don't know borders, right? They're here one day and the next day they're in the United States. And after that, they're all the way in South America. And so if we lose a chimney swift, like this one I found at the Faculty of Information and Media Studies building in 2019, losing a single individual like this has far-reaching consequences beyond our ability to measure just in London. A single chimney swift eats hundreds of thousands of insects over the course of its life. And other types of birds play really important roles in the generation of new forests, in pollinating certain plants, including crops that people consume. Birds provide critical food for predators that feed on birds. And so when we lose a bird like this, we don't often think about the knock-on effects that it has in ecosystems all across the world. And so I think about this often in my work because I think we have a responsibility to recognize our actions extend beyond, a single building, a single window, a single bird, but need to be part of a broad conservation strategy. I also would like to point out that this region in southern America, where chimney swifts migrate to for the winter, is home to the greatest richness of bird diversity in the world. And so thinking about all the interactions that occur there, if we are reducing bird population numbers in North America before they can even make it back south for the winter, that could really mess things up down there in ways that we haven't yet been able to measure. So I mentioned that birds have declined precipitously in the last 50 years. An alarming report was published in 2019 by Cornell University, which found that we've lost roughly 3 billion birds in the last 50 years. This represents a loss of over 1 in 4 birds. And if we look at the reasons that birds are disappearing, the majority of them are anthropogenic. They're caused by people. So looking at the number of species affected on the y-axis here, we see that invasive species is number 1. Agriculture, logging, other forms of habitat modification are also really significant. Looking just to North America, the 2 leading causes of bird deaths are cats, being an invasive species, and building windows, so collisions with structures. And so I like to take this point in my talk, which is not about cats, to just emphasize that if you have a pet cat, please, 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 please keep it indoors. Don't let it wander around outside. If you want to let it outside, take it out on a leash, put it in a catio. In London, we have a bylaw that says it's illegal to let your cat roam. Cats kill hundreds of animals every year, and we cannot afford to lose more. And so anyways, happy to comment on that later if you have questions. So going back to bird window collisions, I wondered, how do we even assess where this is happening and how often it's happening, and what are the human consequences of that? I set up this little side project over the summer. Using social media, we can actually figure out where birds are crashing into windows by monitoring tweets in real time. So I learned that every few minutes, somebody somewhere in the world is every few minutes, somebody is tweeting, "A bird just hit my window. What does it mean? Or what do I do? Or what's going on here?" And so we found this way to connect them with information about how to help the bird and how to treat the window. But it's sort of painting a picture of this being a really broad global phenomenon that hasn't been studied in a lot of parts of the world yet. Another way to do this at a more local level is using community science. So I set up this project using this really cool app called iNaturalist. I highly recommend it. iNaturalist is an app that lets you point your phone camera at any organism in the world. So, it could be a bird, a bug, a plant, a fungus, and it'll tell you exactly what it is, and it'll add the observation to a map. So I set this up to keep track of where birds are flying into windows in London. And we've collected quite a few observations to date just by people reporting what's happening in their backyards. Just here's some of the species that have been reported in London, really quite diverse. So what I want to emphasize is that birds are everywhere all the time. And we can't really think about them as just being contained in natural spaces. By definition, migratory birds move around, right? So, having park space is great, but the birds are not going to respect the borders around parkland. They're going to be coming into your backyard and passing along urban corridors. And so I've wondered, how do we think about our cities a little bit differently to share airspace with birds? I like this picture. This is just showing air traffic control over North America. I think this is fairly representative, but we already have a framework for understanding and respecting airspace for planes. You can't just be shooting lasers up in the air at any time. There are certain rules around airports to prevent collisions with aircraft. So I like thinking about this in a way that maybe we can extend it to how we respect birds and their habitat needs as being beyond just contained in a single property space. So one way we can do this is by changing the rules for new development, particularly around the use of glass and light. So the city of Toronto, New York, and San Francisco all have bylaws that are requiring new development adopt bird-friendly practices. So in particular, the use of lighting that isn't contributing to light pollution, and the use of bird-friendly glass, which I'm going to talk about next. In the City of London, we're working towards that. So I've been working on this project with the municipality for some time, and pretty soon in the new year, all new site plans issued by the City of London will require the use of bird-friendly glass materials, which I think is a big step in the right direction. But it is most likely going to be constrained to only structures that require new site plans. So things like new individual homes, or you want to put up a glass railing, and existing structures are not going to be included, which is why we really need to try and facilitate public participation. So I've talked a bit about bird-friendly design, but I haven't defined yet what I mean by that. To do so, I'm going to cover some basic principles about what a bird-friendly building is and some common misconceptions. I'll talk about some solutions for existing buildings, so structures that are already out there killing birds, and then I'll move to discussing solutions for new buildings, which is probably most relevant to your work. I want to also mention that we now have a federal standard for bird-friendly building design. This is a wonderful resource, and I encourage everybody to look it up. This is available to read for free online, and I've included a reference to it later in the talk. So I'm not going to go through everything on the slide, but just as a general overview, there are benchmark criteria for how to structure a building so that it's bird friendly. I mentioned before that most collisions happen up to the 4th story. That tends to be the most common places where birds are flying, and that's where they're going to hit the window. And so generally speaking, the expectation is you want to treat up to that 4th story, or 16 meters in height. And you want to achieve 90% coverage. So if you are talking about a building that has, let's say, 100% glass, at least 90% of that would have to be treated. You want to make sure that you're not missing anything. So if you've got atria or courtyards in the building, those need to be treated. If there are any places where you've got parallel panes of glass that could create the impression of see-through conditions, you want to treat those. So corridors or hallways sometimes have windows on either side. That can be a really common place where birds crash. I mentioned there are criteria for lighting, so it needs to be shielded and pointed downwards. You want to make sure that you're just not spilling too much light from the interior of the building as well. And lastly, landscaping is important. It tends to be that birds crash into windows that are near vegetation, probably because the birds are hanging around in the vegetation. So planting trees a suitable distance away from the building can be beneficial. So I want to talk about some misconceptions and ideas for treating windows that just don't work, unfortunately. And these have become popularized for different reasons. So one that I think a lot of people are excited about, but has yet to be scientifically proven, is the use of ultraviolet signals for preventing collisions. So there's this product you can buy at virtually every hardware store called Window Alert. It's often a little maple leaf or shape of a hummingbird or butterfly. And the claim is that because birds can see into the ultraviolet spectrum, but people can't, the ultraviolet signal is going to be really salient to a bird. They're going to avoid it. And you're not going to have your window be too obscured because you're not going to be able to see the pigment. There's very little proof that this works. And unfortunately, we still see expansion of this market. These products have become super popular. We have new types of glass that are appearing that have UV signals baked in. And I'm not confident with the evidence that this is effective. So I would recommend avoiding ultraviolet when choosing a bird collision prevention method. Another common one is people will take a single silhouette, a sticker, bird of prey is really common, and they'll slap it up on the glass. And the problem with this is that birds are very used to avoiding obstacles when they fly. Thinking back to birds in the forest, birds are able to dodge between branches and tree trunks. If there's one object in the way, they're just going to fly around it. So looking at this window on the right, the bird is probably not going to smack into the one sticker you've got, but it could easily fly below or above and so on. And so, thinking about this, This is not an effective application because birds would go around it, but really nobody wants their window to look like this. You're not going to want to take a million stickers and totally coat your window because then your window is not functional. Another common one, people will tell me, well, I closed my curtains so birds won't crash into it. And unfortunately, this doesn't do anything to break up the reflection on the exterior of the glass. This one is still really popular. I don't know why people think birds are afraid of these. You'll see like a decoy owl or something. Birds don't care. They're not going to avoid that. So what does work? Here's some general principles that have been endorsed by experts. You need to treat the outside surface of the window. You can't put it on the inside because if you put it on the inside, it's not going to break up the reflection. By putting it on the outside, light that's bouncing off from the sun is going to interact with whatever you've treated the glass with, hopefully dampening the reflection. You want to make sure that you're covering the entire window and not just putting up 1 or 2 stickers. You want to reach edge to edge, and you don't want to leave any gaps that are wide enough for birds to pass through. So generally speaking, the criterion is you want to have markers that are spaced no wider than 2 inches apart. And you want to select markers that are going to provide decent visual contrast against the background. So if you're looking at a dark window, you probably want to use something that's lighter in color and vice versa. I mentioned the marker spacing being important, and here's just a depiction of why. If you have a bird that's flying towards the window, the current thinking is that birds are pretty bodily aware of how much space they take up, and they're not going to try and pass through something that they can't fit. So the smallest birds that are prone to collisions are hummingbirds and ruby-crowned kinglets. Their wingspan is not going to fit within 2-inch gap. So I just included a few examples. I've broken these into the same categories I mentioned before, just to sort of provide you with a demonstration of the principles. And if you have a window at home that's killing birds, these can be really simple techniques to stop that from happening. So a popular product that I quite recommend is called Feather Friendly. So this is sold in a roll of tape you see in the top left. You apply the tape, you peel it off, and it leaves a grid of dots every few inches. I like this because it's very unobtrusive. Most people don't even notice it after it's been on your window for a while. The window I'm facing in my backyard right now has it, and I don't even pay attention to it anymore. And you can buy that locally at most bird stores in London now. If you're in a bind and you don't have resources or time to go shopping, I mean, even just putting up basic tape will do the job. What's really important, again, is that spacing and breaking up the reflection. There's other types of tape you can buy, like automotive tape, that are more sturdy and will last a longer time. Like this example. People have gotten creative with it. In zoos, actually, there was problems with animals being brought in, not understanding that the glass walls were an obstacle to them. And so they solved this problem with masking tape. Some people go further and they'll use bubble wrap. I haven't tried that, but it looks like fun. This is another popular one, and it's quite effective for large structures because it's economical. So it might be hard to see from the pictures, but these are actually pieces of string that are suspended from the top down. And so, looking at a home window, this is relatively easy to install. But I've seen larger versions of this at bigger industrial buildings where you've got it fixed at the top and bottom. You can use industrial cord or something similar. Again, the spacing is quite important, but this is a nice way around having to actually modify the glass and instead putting something on the exterior. There's lots of other DIY craft ideas I've seen on the internet. People will decorate their windows using paint or stickers. So you can go and buy oil-based markers and just treat your window like a canvas if it suits you. I like the idea of redefining windows as a canvas because I think it actually offers a means of enhancing the aesthetics of a building. So here's just other ways that people have gotten creative with it. Here's stickers that somebody put up for Pride. And screens and netting are also recommended. If a bird smacks into a screen, it's most likely going to just bounce off and not be injured. So for commercial and larger buildings, obviously, you're not going to be able to take a marker and draw a mural that spans a huge structure. But there are a variety of products now available for modifying basic glass, but also specialized types of glass that are intended to be conspicuous to birds. So here's an example. This is acrylite. It's often used in noise barriers and glass railings. The important thing to note is you've got these lines that are embedded in the glass. Walker Glass offers a variety of variants of their AviProtect glass. So you can get vertical, horizontal, dots, other types of patterns. These are all commercially available in Canada now. This uses a method called acid etching to embed it right in the glass. So it has quite a long life. Here's another type of glass that's low emission, so it's less reflective. It is a different aesthetic. Of course, it's going to be translucent and not allow the same transparency through, but might be suitable for certain projects. There's a variety of window films you can buy customized. So here's just a couple examples from Kaleidoscape. And I mentioned Feather Friendly before, the roll of dot tape. They offer a commercial solution as well, which is available in different configurations. The Western Interdisciplinary Research Building I showed at the beginning of my talk has this film applied to it. And as a result, we find very few dead birds there. So it just leaves behind this grid of dots that birds will recognize as a solid object they can't pass through. Here's just another couple examples of glass structures. So a tennis court, transportation shelter. The University of British Columbia recently retrofitted a whole bunch of windows in a nice creative manner. Same at the University of Manitoba. Here's a recreation center. So I think you get the impression that there's a lot of variety out there. There's a lot of flexibility in how you modify your windows. You just want to make sure that you're complying with best practices and working with your clients to make sure that there's a good mutual understanding of expectations. So one thing I want to just touch on is, how do we know any of this stuff works? I don't expect you to take my word for it. The way that we do that right now is through a method that's called tunnel testing. And this relates to my research. So there's a group in the United States called American Bird Conservancy that certifies these products as effective. And so generally, if you find this label on a type of glass, you're probably okay to trust that it's been endorsed and is effective. This is what their procedure looks like. They operate a tunnel where they're taking a bird. So in the top left, there's a woman holding a bird in a bag. It's probably pretty pissed off. They put it inside the opening, like the woman in the blue sweater, and the bird flies down a dark corridor, like you see in the bottom right, towards two panes of glass on opposite sides. And depending on which side the bird flies on, the control versus the treatment, they can assess, did the bird detect the pattern or not? And that has formed the basis for understanding which types of patterns are effective and which are not. There's a variety of limitations of this method, and I don't have time to get into them, but happy to answer questions if you have. But I think there's a lot of room to improve here, and that's something that I'm working on for my PhD. One is that we haven't really thought about how birds see this stuff. We're just looking at their behavior, avoiding, do they fly to the left or fly to the right? But we're not really getting into a bird's head and trying to model what it's actually doing. And so the way that I'm going about this is by using what's called visual perceptual models, where we teach a computer to see like a bird, and then we ask the computer, how much is this going to stand out to the bird? And then we can test predictions of that model through experiments with animals. So I want to, just a second. Computer, stop. I have a home assistant that just chimed in. I want to take you back to this image, which was the Indigenous landscape in Southern Ontario that I started my talk with. I mentioned that I think it's really important framing the problem within this, because birds evolved their sensitivities, their ability to see, to allow them to thrive in this environment. And so a lot of the features of bird vision are centered around how they interact with the natural landscape. So for example, birds can see into the ultraviolet spectrum. This helps them to find food and to select appropriate mates. Birds have a higher density of photoreceptors at the center of their eye, so they've got greater visual acuity. And they have two foveas. So this is maybe a little complicated to explain, but the center of your eye, where you have like the most detailed perception, birds have two of those. So they can maintain focus on different places at the same time. So I think about all of these features as being really important to addressing how we treat windows that in a way that will be maximally conspicuous so that they'll always stand out to birds and they're not going to crash. I work out of this building. This is the advanced facility for avian research at Western. Not a lot of people know about it. It's sort of tucked away beside the forest. We've got a really cool hyperbaric wind tunnel there in the bottom left, and it's allowed us to do some really cool stuff like filming the movie The Messenger there. We do all kinds of research on bird migration and physiology, senses, that kind of thing. So what I'm doing right now is I've captured a bunch of house sparrows. These are an invasive species. And I'm doing these experiments with them where I'm flying them through an apparatus. This is my little dummy version that I'm playing around with. And we're trying to find out how birds are actually behaving as they're approaching a window that has a treatment applied to it. And that will potentially allow us to model the processes of visual detection and avoidance. So here's my rig inside of this apparatus where we've got multiple cameras and infrared beams to detect the bird. You can see I've treated the sheet of plastic with feather-friendly dots. And so we're starting to get a better sense of what this looks like. When birds are crashing into the window, what happens before and after? Are they detecting it? Are they smacking straight into it? Are they looking with two eyes or with one eye? These are all, I think, really important components of building that mechanistic model. So like here's an example of a trial using the tunnel where you see me in the back release the bird. This would be avoidance. So the bird detected and it flew to a perch in the top. This is another one where the bird realized, oh, there's something here, and it just sort of turned around and avoided it. These are all phenomena that have not really been documented before, because typically when we observe collisions in the field, the bird is already dead. So being able to simulate this in an experiment is really valuable. The ultimate version of this is going to be built outdoors. We want to be able to incorporate natural sunlight and use a bigger, more flexible apparatus. And the goal is to develop a paradigm that will allow us to test different types of commercial product for effectiveness. So I'm going to wrap up here. I want to leave you with some just take-home messages. Collisions with windows on buildings are a big conservation issue for birds, particularly in the built environment where we see the most glass. There are already solutions for preventing birds from crashing into windows, but a major limiting factor is that we need to educate practitioners, potentially like you, to be aware of those and to use them. However, there are products out there that are labeled as bird friendly, but unfortunately are not effective. And so it's really critical to stick to best practices, such as following the Canadian Standards Association guide or looking to non-government organizations that specialize in this space. We talk a lot about sustainable development nowadays, and I think we need to expand our idea of sustainability to encompass impacts to the surrounding ecology. So we cannot just focus on the inputs and outputs of buildings, but think about how do buildings interact with the surrounding environment, including preventing unnecessary bird deaths. So I'd like to thank you for listening to my talk. I've included some resources here in case you want to learn more about bird-friendly stuff. You can follow me on Twitter if you want to follow my crazy bird adventures, and I look forward to taking your questions. Thank you.
Thank you very much, Brandon. Very interesting talk. All right, everyone, for questions, you can use the chat window or unmute yourself and ask the question. So when you compare the rate of fatalities of birds compared to the overall other factors, natural or artificial factors that kill birds, what is the ratio?
So we know that humans are driving the population declines that we're seeing, particularly in migratory birds. It's understandable that there's a certain amount of baseline mortality that occurs each year. You know, some birds just don't make it through the winter, some get predated upon. But a real tricky problem is dissociating all of these different ways that people are affecting birds. And there's interconnectedness between these factors. So for example, a lot of the time a bird hits a window, it doesn't die right away. The bird might be wounded, it's sitting on the ground, it's stunned with a concussion, and that makes it much more liable to being picked up by a cat that just walks by and finds a free lunch. When we, so there are facilities that take in injured wildlife, and a lot of the birds that they receive that have been injured by cats are species that a cat would otherwise have no means of capturing. Like, how does a cat catch a woodpecker? It's sort of a crazy thing. And so not a lot is known about it, but it's thought that maybe birds are crashing into windows and that's making it easier for cats to capture them. I would say that cats are the #1 way that people are killing birds. There tends to be consensus around that. Buildings or collisions with windows on buildings hovers around the second or third leading cause. Those are direct sources of mortality. But then you have habitat loss and climate change, pollution. Those are more indirect sources and they're much harder to measure.
And well, just another question I have is related to cats. So aren't cats part of the nature? And you know, one can argue that when you say keep the cats at home, you're keeping away an animal just to save another animal. If you can
So
clarify that.
it's a great question, and I've been asked this a lot. Cats are extensions of people. The reality is, if there were no people, there would be no cats. The cats that we enjoy, that we see in our cities everywhere, were imported. They're not native to this area. And so I believe they should be classified as an invasive species because what they're doing is they're negatively impacting the wildlife that has existed and evolved here for millions of years, whereas cats have only arrived in the last century as a result of people. When you allow a cat to roam outside, there's all kinds of other harms that you're risking for the cat itself. So cats often get hit by cars, they get picked up by coyotes, they get poisoned. If they eat a mouse that has eaten poison, you know, they get sick. And so there are good reasons for why cats should not be allowed to roam. It's why we have a bylaw. But I understand that it is a sacrifice that is expected of pet owners to keep their animal contained. Another way to think about it is if we were to allow dogs to roam everywhere, if you didn't need a leash for your dog and you just opened the door and said, see you later, I mean, I think that would make a lot of folks uneasy. And I think we need to take that double standard and try and treat cats the same way.
Okay, thanks. A question from Samuel. Is there anything you do in your experiments that help prevent the birds from dying when they run into the window?
Great question. So I didn't explain it very clearly, but this actually has an engineering component you might find interesting. So the experiments I've done until now, we're not using real glass. We're just using a very lightweight sheet of plastic, like the sort of thing you would wrap food in. It's actually insulation film for a window. And so when we do this, the bird bounces off of it and shows very little sign of harm because it's just, it's very elastic and flexible. But ultimately, you know, plastic sheets are not the same thing as glass, and we need to test with glass. And so starting in the new year, we've engineered a mechanism that will shoot a mist net, a net, like a very lightweight net, right up in front of the glass before the bird crashes into it. The bird breaks through a series of infrared beam sensors, and that sends a trigger pulse, which causes the net to shoot up. And so all of this is being designed very carefully to avoid causing harm to the animals. We don't want them crashing into things and getting hurt or dying.
Interesting, thanks. Although I see the benefits for birds of putting dots or art on your windows, I assume this is unappealing to the vast majority of people. Is there work on any less intrusive solutions?
Yeah, so, you know, there's this trade-off that we have to navigate. And I think appreciating the human dimensions of the problem, as I said, is really, really critical. We need to understand consumer expectations and that people want their windows and buildings to look a certain way. Because if we ignore that, then they're not going to want to adopt these solutions that don't look good. I think having people be able to see what the windows look like when they're treated in the real world. So examples in your community where you can go and look at a bird-friendly window and say, hey, that's not so bad. that might be a good way of changing minds, but there needs to be a clear boundary of this is what is necessary for a bird to see it. Otherwise, we run into a territory where we're trying to get things to be invisible, but the point of it is to be visible. So like the grids of dots, for example, if you don't like those in white, maybe you'd be more inclined to try them in black, or just very thin lines, vertical or horizontal, or something like that. I can't speak to whether the public is going to be willing to adopt that or not, but I do think we need to recognize that if we don't do anything, we're causing harm to the very same animals and nature that we want to be able to see through our window. And so what is the acceptable compromise for a homeowner to say, hey, it's not going to be a perfect crystal clear image. I can still see out my window, but I'm going to do my part and put up these markings so that I'm not causing harm. Yeah, it's a tough psychological problem.
Interesting. Thank you very much, Brendon. Very interesting talk. We have a few more questions. But unfortunately, we run out of time. I encourage those who have more questions to be in touch with you. We see your Twitter account.
I'll put my email in the chat.
Perfect.
Here, you can email me if you've got questions.
Great. Thank you very much again, Brendon. Very interesting. I really enjoyed it personally.
Thank you.
Thank you. And thank you all for attending our last civil seminar for the fall term. So we will restart our series in the winter. See you all next term. Thank you. Bye-bye.